Hello friends, myself Vishnu J, currently studying in Sri Venkateswara College of Engineering. Subject is operating system. The title currently I am doing is Build Your Own Operating System for IoT Devices. Introduction: IoT extends early wireless sensor networks to more applications. Example: smart cities, healthcare. The diverse and growing demands of IoT devices requires flexible software solutions. Existing systems like TinyOS and FreeRTOS are often either too rigid or not optimized for every use case. Key challenge: creating a general purpose OS for IoT device is inefficient because it adds unnecessary features. Special purpose OS development is time consuming and complex. There's a need for OS system that provide the exact functionality required efficiently. Example: thread-based models are suited for concurrent process, while event-driven models are optimal for sensor-driven tasks. Our approach: Tinkertoy, a modular collection of building blocks for assembling application-specific IoT operations systems. Main advantages: developers pick only the components needed. Custom systems tailored to device constraints and applications needed. Up to 4x less memory usage without runtime performance loss. Inspired by unikernel and library operating system, which also aim to optimize for specific applications by trimming unnecessary features. Architecture overview: core modules, scheduler, memory allocator, context switcher, dispatcher, kernel service routines, task control block, device drivers. Each module can be customized or replaced depending on the application's needs. Target devices: low power ARM Cortex-M processor with limited memory. Example: sensors, communication hardware in smart homes or industrial IoT. Modules of Tinkertoy scheduler manages task execution, can be primitive, switch tasks by time slice, or cooperative. Memory allocator allocates and reclaims memory efficiently with specialized allocators for constrained devices. Context switcher manages switching between tasks or handling interrupts. Dispatcher routines requests from tasks to kernel service routines, implements system call and handles device interrupts. Task control block contains task specific data. Execution models supports both thread based and event driven task modules. Schedulers purpose decides which task runs next and for how long. Scheduler policies FIFO, first in, first out, priority queues, tasks ordered by urgency, primitive, switches tasks after a time slice, good for concurrent real-time application, cooperative, tasks run until completion or vulnerability yield control, customization, developers can replace or modify scheduling policies based on application needs. Example: switch between round robin or rate monotonic scheduling. Memory allocator. Memory is scarce on IoT devices, so efficient memory management is critical. Allocators. Free list allocators. Tracks free memory blocks for allocation. Binary buddy allocator allocates memory in power of two sizes, reducing fragmentation. Pool allocator allocates memory from fixed size blocks, ensuring last allocation. Customization: developers can customize the allocator for different memory usage patterns. Example: sensors data versus communication buffer. Context switcher handles switching between user tasks and the kernel. On interrupt, the context switcher saves the current task state and transfer control to the dispatcher. After servicing, the context switcher resumes the next task execution state stored in task control blocks, ensuring tasks can be resumed from the point of interruption. Dispatcher. The dispatcher coordinates between tasks and kernel services routines, uses a service identifier finder and service routine mapper to route service requests to the collect handlers. For example, interrupt requests RIQs are handled by identifying the service and mapping it to the corresponding handlers. Comparison results. Memory footprint. Tinkertoy 1.5x to 4.7x smaller memory footprint compared to free RTOS and Zipper. Z control block in Tinkertoy is highly customizable and optimized for application specific use cases. Runtime of performance. Tinkertoy outperforms other systems due to optimized service routines and more efficient task management. Conclusion. Tinkertoy allows developers to create custom IoT OS efficiently, managing specific application needs. Benefits. Smaller memory footprint, high performance, flexibility in OS design, supporting both thread-based and event-driven modules. Future work. Extend support for more devices, synchronization mechanism, and further optimize for multi-threading environments. Thank you so much for watching my video.